livestock integration, agro ecosystems. We've got very lively photos here for this beautiful person. We hope more people will join, but we wish to start on time. So yes, for those who haven't met me before, I've been managing and facilitating this series for AFSA and for Sky since this started. I'm an advocacy. Can we just mute everybody? Let's put everybody on mute, and we can open mics a bit later. So I'm Sasha.
Sorry, Sasha, unmute. Sorry. You have to unmute, Sasha. I just clicked on mute off. Sasha?
Sorry, and so the moderator gets muted as well. So good morning again, everyone. I'm Sasha. For those who don't know me, I've been moderating these very exciting sessions on healthy soils and healthy food systems on behalf of the Seed and Knowledge Initiative and the Alliance for Food Sovereignty in Africa. And today we are launching into a 6th of an 8-part webinar series. And to introduce this series, for those who don't know about it, I would like to ask Stephanie, I don't know if you're in the room yet, and Charles to be on standby to briefly present your organizations. For those joining us from West or Central Africa, if you want to get the benefit of the interpretation, please go on the interpretation tab that you will see at the bottom of your screen. Pour ceux qui ont besoin de l'interprétariat, cliquez sur l'onglet de la petite sphère et vous pourrez activer le français pour bénéficier de l'interprétariat. Stephanie, no, Charles, sorry, let's begin with you. Do you want to say a few words about AFSA, for those who don't know AFSA?
Thank you so much. My name is Charles. I work for the Alliance for Food in Africa, AFSA. AFSA was launched in 2011. It's an alliance, not an NGO, of civil society actors who are advocating for food sovereignty and agroecology in the African continent. AFSA is made up of 40 members, and these are networks of networks operating in 50 of the 54 African countries. AFSA also promotes African-led solutions, bringing together traditional knowledge, merging it with modern-day science, bringing in issues of natural resource control and management. So in brief, I would say AFSA champions 4 key issues: one around climate change action, another one on farmer-managed seed systems, the third being on land rights and healthy soils, and the 4th on sustainable food and nutrition systems. In case you need to learn more about AFSA, I am going to put the website in the chat so you can get more information. Thanks.
Thank you, Charles. I'm trying to see whether Stephanie Aubin has joined the meeting. I'm not sure she has.
No,
so Steph, unless you manifest yourself. Ah, there you are. Please go ahead with introducing Sky.
Thanks, Sasha. Good morning, everyone, and Happy New Year, everyone. Yes, my name is Stephanie, and I'm with the regional coordination team of the Seed and Knowledge Initiative, Sky. So Sky is a regional partnership of 15 diverse organizations, including local NGOs, community-based organizations, farmer organizations, research institutions, national networks. And this organization came together in 2014 to promote farmer-led systems in the context of agroecology and food sovereignty in Southern Africa. So we work both at the grassroots level, supporting farmers, and at the national, regional, and global levels, doing some advocacy work there. And so since 2020, we've been collaborating with AFSA to jointly design and implement the Healthy Soil, Healthy Food initiative, which is the initiative that is offering this series of webinars. So we have 6 partners who are hosting Healthy Soil, Healthy Food centers. So it's SFHC in Malawi, Kasisi in Zambia, Tsuro and Poret in Zimbabwe, as well as Chinika and Bawach in South Africa. So the 6 partners are hosting the center, leading the Healthy Soil, Healthy Food movement in the region and in the partnership, and the regional team, we provide coordination support. So if you want to know more about Sky, I'll also put the address of the website in the chat box. Thanks, Sasha.
Thank you very much, Stephanie. And the initiative that Stephanie was speaking about, the Healthy Soil, Healthy Food initiative, which we are having this webinar series as part of, that's what I was screening just now. We have traveled quite a long journey since October last year. I think most of you would have been in the previous sessions. And we've done a lot of focus on managing soil fertility, traveling all the way to crop health management, seed management technologies, how to involve pharmacists, farmer managed research in our trials, and also looking in the last session at healthy agroecological farm input markets. And so today I'm very excited because I think it's one of the most exciting elements of agroecological systems is the integration of livestock in agroecosystems. And we know how important the integration of livestock and diverse animal systems, including aquaculture, for instance, which we'll be focusing on today as well. These play a seminal role in managing the health and the fertility of the soils, and multiple interactions end up playing out within the living organism that is the farm. And animals intrinsically form part of a lively, vibrant, well-balanced agroecosystem. So we're going to be looking and taking a deep look into some of these approaches that can help with regenerating drylands and enhancing soil fertility. The specific questions we will be seeking to answer today is to understand how can holistic land and livestock management approaches be used to integrate cattle and goats, for instance, in landscape level agrosystems for cell health improvement. We have a speaker here, Precious from Zimbabwe, who will be telling us about this. We will be zooming also on a very specific animal production system, which is poultry management. So we have Dr. Sabir Sashi here from India, Andhra Pradesh. He will be sharing some very exciting systems that have been designed and implemented in India. If we can just identify who's unmuted there. And another aspect of animal production we opted to zoom on today is the integration between aquaculture and horticultural systems. And we have Stephen here from Zimbabwe as well, who will be telling us about these. So we opted for these sessions to, rather than give you just a very broad picture of, how animal production systems integrate into agroecosystems, we decided to give a very sort of more in-depth focus on specific animal systems so that participants can really take some important learnings and takeaways from it. Hence the focus on livestock management, poultry, and aquaculture. And hopefully we can have a broader discussion looking at other animal systems once we've received the input from our presenters today. Just some quick housekeeping before we start, and I will be very brief. You're welcome to drop your name and organization in the chat box. We also like to please ask people to put their credentials on the Kobo Toolbox link, which Charles is going to be dropping in the chat box now, because it makes for easier management of our database. Also, before we start, we like to bring up a little poll on the screen, which is going to ask you, which organization or which type of stakeholder category you hail from. So Charles, if you can bring up that Zoom poll, I'm going to stop my screen share, and we're going to ask people to please look at the window in front of you and asking you in which way you are involved in the agroecological sector. Are you a farmer, a researcher, a trainer? Are you from an NGO, the private sector, an international organization, from governments, the donor community, or are you just not involved and curious to become involved? So this is nice to give our speakers just some perspective on who's in the room. So we'll give sort of 10, 15 seconds for this process to unfold. Okay, we've reached over 70% of participants. So we're just going to end the poll and look at the results so that we can see who's there. So I think people can see my screen. We have essentially people hailing from the NGO, CSO sector, the majority of participants. 20% farmers, 8% researchers, 11% trainers, some representatives of international organization and government. So this is interesting. In the previous webinars, we had up to 50% farmers in some of the sessions. Okay. So thank you for this. I think this is a good overview of who's in the room. And I think with no further ado, I'm going to be introducing our first speaker for today. He will be telling us about aquaculture and horticulture systems design and how these integrate based on an experience in Zimbabwe. So Stephen, if you want to please be ready, switch your camera on. And Charles, if you can just bring up Stephen's PowerPoint on the screen, that would be great. Stephen, I'm going to briefly present you. Stephen Maji Shupai is an animal scientist with a passion for community development. He's currently the programs coordinator at Tsuro Trust in Chimanimani, Zimbabwe. Stephen also lectures in diploma level courses and works as an agriculture consultant in the fields of dairy, apiculture, and agribusiness. So we have with us a person with great animal management expertise. Stephen holds a BSc degree in animal science and an MSc in applied microbiology and biotechnology. Stephen is also a Mandela Washington Fellow. So we're going to invite you to please go ahead with making your 10-minute presentation, Stephen. And we're going to ask participants to look at the, is the Q&A box up? I'm not sure we have the Q&A box up. Any questions that participants may have and that might emerge, please drop them in the chat box. And we will be directing all those questions to the speakers, and we will have an open discussion on all the presentations once these have been completed. So, Stephen, the floor is yours.
Thank you very much, Sasha, and greetings everyone from Chimanimani in Zimbabwe. So as indicated by Sasha, I'm Maji Shupai Stephen. I will take just 10 minutes to share our story from Zimbabwe. Specifically, the story is coming from the eastern highland of Zimbabwe, Manicaland region, from Dasa district, and our experience in Chimanimani as well. So by way of context, the eastern highlands in Zimbabwe is generally characterized by high rainfall, very good food security situation, but we also have a very bad nutrition security situation. Despite the very heavy rains that we receive here, we have lots of perennial water in our rivers, and because of this context, the idea of trying to support our farmers, their livelihoods, their nutrition in the face of climate change came up, and this is how we stumbled upon the idea to try and see how we could integrate fish farming, taking advantage of the vast water resources that some places in the Eastern Highlands region of the country enjoy. And so far, in brief, our experiences have shown us that integration of fish farming into horticulture and other agriculture activities has been seen to be very good at improving household animal proteins. We have seen also an increase in income generation capacity by our farmers, and also a very high scope of income diversification. Our stories and experiences also show that this integration can also provide leisure and hobby options and a very big aesthetic function for our older generation. We have a story of an old lady whose sons were trying to find something good for her to occupy her in her old age. And when they introduced fish farming to her, it played the trick very well. And she had a lot of benefits that she could testify about: the quality time she would spend by the poolside, catching fish for customers, weighing them, selling them from there. So we have lots of stories, interesting stories about the aesthetic function and the leisure, the hobby function of fish farming as a component of integrated livestock crop systems. Then in the face of climate change, we've also discovered that fish farming provides us with an opportunity to ensure multiple uses of scarce water resources, which is critical as an adaptation option for our farmers as we face water scarcity caused by climate change. Then, like I indicated, the pilot phase that I'm talking about and the experiences span from 2015 in Mutasa and 2020 from Chimanimani. So we're just summarizing experiences got over the past 9 or so years, starting with Mutasa, then into Chimanimani. Next slide, Charles. The theoretical framework from which we borrowed this idea is shown here, which is essentially summarizing the possible connections that fish farming can have with goat farming, pig farming, and poultry farming. Essentially, the relationship is such that waste materials from one enterprise can be used as raw materials for the other enterprise, as shown by this schematic diagram. So in our case, we decided to integrate fish farming with horticulture and a bit of poultry, in the sense that we would get poultry manure to use it to fertilize our ponds, so that we have the growth of natural algae within the ponds, photosynthetic microscopic plants that fish feed on. Then the water that comes out of the fish ponds is the one that then goes to irrigate our horticulture crops, since it will be nutrient dense and it can safely replace our synthetic fertilizers that we normally use in conventional agriculture at a very reasonable cost to the farmer. Next slide, Charles. So our story began with a farmer in Mutasa, Mrs. Maifa, who had a 15 by 20 meter night storage dam, which was constructed initially to store water during the night so that she could use it for irrigating her horticulture crops the following morning. So when he started thinking about introducing fish farming, she volunteered to have a night storage dam converted into a fish pond, and she stocked this fish pond with about 2,000 fingerlings of fish. And she did very well. The fish grew very well. She managed to secure a formal market in town in Mutare, and she got some nice return for investment. But besides getting a very nice return on investment for fish farming, one thing that surprised here is that as he was taking the water by gravity from the night storage dam converted to the fish pond, the horticulture crop that she was irrigating downstream started performing far much better than before. And that's when she started trying to find an explanation to that. And upon interaction with the extension sales providers, she learned that there's a lot of organic fertilizers or nutrient-rich water that was draining from the fish pond to fertilize a horticulture garden. And that's when we started to try and see, to explore the extent to which that nutrient-rich water from the fish ponds could benefit farmers, horticulture farmers, as they irrigate using that water to irrigate their horticulture plots downstream. So we established demonstration sites at several schools in Mutasa. Next slide, Charles. So the next picture there is showing some of the demonstration sites that we established at one of the schools to try and further validate their findings. And we confirmed that besides getting a very good harvest of fish from the ponds, the water that drains from the fish pond is nutrient rich, and it can be used as a very good fertilizer to fertilize horticulture crops downstream. So that was a field day to try and witness together with the school children and learners, the teachers and the community, what the experience of this school was in terms of this integration between fish farming and horticulture. Next slide, Charles. So in both cases, we managed to find results that were convincing that nutrient-rich water from our fish ponds can be very useful in terms of fertilizing our crops. And in an effort to try and explain what could have been the source of these nutrients, we figured out that in the process of culturing the ponds, because when we established our ponds, we wanted to promote the growth of microscopic plants, which we call phytoplankton, within the fish ponds. So we normally use poultry manure, put it in a sack, then immerse the sack within the fish pond, and the water turns green. It turns pea green, and it turns pea green as a result of the growth of microscopic plants called algae, which becomes the primary diet of the fish. So besides promoting the growth of algae, which is the primary diet of fish in our natural rivers, we also make available these nutrients from our organic fertilizers, our organic manures, to be available after our fish production cycle, as we use the water to irrigate our crops downstream. So that was one source that we could establish of the nutrient-rich water flowing from the fish ponds to the crop fields. Then we also figured out that the waste materials coming from excretion of the fish as they grow and breed within the fish pond also contributed to enhancing the nutrient density of the water that then flows out of the fish ponds. And the picture to our right is showing some lady farmers demonstrating what we call the elbow testing, which is very critical. As we fertilize the water in the ponds, it is very important to monitor the density of the pigmentation of the water, so that we don't create a lot of competition between the microscopic plants and the fish, especially during the night. So we normally do the elbow testing, where we dip our hands into the water up to elbow level, and then use that as an indication of whether our pond is over-fertilized, is adequately fertilized, or is under-fertilized. So that's what the ladies on the right are demonstrating there. Next slide. So after our various experiences with our farmers, normally they would put their ponds at the high end of the catenary, so that water from the ponds drains by gravity to fertilize irrigation, to fertilize crops downstream. So we started having a lot of uptake of this idea from many farmers, as shown on the diagrams there, despite the fact that some of the farmers would not really adopt all the principles proposed within our agroecology principles. But generally, a lot of farmers got excited and started setting their ponds in such a way that water from the fish ponds then drains by gravity to fertilize their crops downstream. And the results that we have received so far are very promising, both in terms of the quality of the crop that then is produced, and the reduction in costs of external fertilizers, and the improvement in the yield of the fish that feeds into the household nutrition security at our community level. So the results that we have got so far, next slide, Charles. The results that we have so far from both of the districts that we've been working with are very promising. And these are some of the pictures coming from one of the schools here in Chimani Biriri Primary School. We were getting an average of about 500 grams of fish, each fish weighing about 500 grams at 5 to 6 months across both of these districts, especially in the warmer parts of the districts where we have lots of water, but the temperatures are a little bit high, averaging about 30 during the daytime. So these are the results that we got, and they're very impressive in terms of improving household income security and diversification, household nutrition, and also reducing the cost of production for our horticulture plots for our farmers. Then in terms of the challenges that we had in the process in both districts, Next slide, Charles. Before I get to the challenges, the strategy that we used to get this thing out there to the farmers, number one was establishment of demonstration sites where we would bring farmers to come and see and witness how these things could be done. Then after establishing the demo sites, we learn together with our farmers and communities and also learners from our schools. We'll then do field learning events where we'll bring people to witness the results of the various things that we have done there. Then in terms of challenges, one of the key challenges, depending on the location of the ponds,
Stephen, if you can just wrap the challenges in 30 seconds, right? Because your time is up. Thank you.
Thank you. So our main challenges were theft of market-ready fish and seasonality of water access in some places, and of course predators in the natural environment. Thank you very much for your time, for the time you gave to listen to our story from Zimbabwe. Thank you.
Thank you so much, Stephen. What a wonderful presentation, bringing in the human element and the spiritual element as well, and the aesthetic pleasure of embedding such systems on a farm, a productive farm. You know, your challenges obviously left us wanting a bit, so we wanted everybody to present the challenges that they encountered, and we will obviously have more discussions around that. And I'm dying to hear how you've dealt with your predator problem. Thank you so much. We're going to be moving on to our next presenter. If you've got any questions, please do not hesitate to drop them in the chat box so long, and we will make sure to direct them to the speakers if they miss them. I would like to ask Dr. Sabyasachi to be ready with bringing up his PowerPoint presentation as a screen share. And while we do so, I'm going to briefly introduce Dr. Sabyasachi, who hails from Andhra Pradesh in India, or at least I know that's where you are actively farming and operating. So Dr. Sabyasachi Das is an agroecology expert with a very rich background in working with pastoral and rain-fed farming communities across India. Dr. Sabyasachi holds a PhD from the National Dairy Research Institute, ICAR, from Karnal, Haryana. He has through his career played an important role in reviving the dairy sector in India, in protecting animal genetic resources and in registering indigenous livestock breeds, working alongside various government entities and the National Bureau of Animal Genetic Resources. Since 2017, Dr. Sabyasachi Das has been the national coordinator of the Revitalizing Rain-Fed Agriculture Network, known as RRA, which is a collective that holds over 800 affiliates across the network. It collaborates with national and international agencies to foster policies and investments that enhance rain-fed agriculture, underscoring Dr. Das' dedication to agroecological advancement. So, Dr. Sabyasachi Das, obviously your expertise on animal husbandry is multiform. We asked you to pick out some lessons learned from the poultry management, to share some very exciting stuff that was being done and pioneered in India for small-scale poultry management. So because we felt this was highly relevant to our small-scale farmers in Africa, that is the topic we asked you to present today. So the floor is yours, and thank you so much for joining us from India.
Thank you, Sasha, and thank you everyone for joining this and actually giving me opportunity to share some of the experiences that we have learned together with the community as well as together with the several civil society organizations. Very quickly, the network, as Sasha has said, it looks for revitalizing rain-fed agriculture, both in the drylands as well as high rainfall rain-fed agriculture. And we try to ask for a lot of public investment, the way that is required for the rain-fed. And with the several things, whether starting from the seed conservation to the soil management to the livestock, the fisheries, several aspects we work. And one of the aspects is looking at how we actually integrate the agriculture, livestock, fisheries together into an agroclimatic zone and through an agroecological processes. So I'll be sharing this my experiences, particularly in case of a poultry program. And this is a program that we actually worked it out initially with the CSOs, civil society organizations / NGO, but then our purpose was how this can be integrated into the government system, the mainstream government system, and why we actually try to look at the native chicken. Sometimes I will talk native chicken is equal to desi poultry in India. So native chicken, because 84% of the chicken that we see in the rural backyard in the country, 84% of them are native chicken. And if you look at the government investment for the native chicken in India is actually zero. And it is, when I'm saying zero, it is zero from the central government. So we thought that the poultry is very, very important. The native chicken is very important because they have an inherent strength in certain things. One, it can easily, and there is a lot of local knowledge associated with the native chicken, because more than 80% of the rural population in India are rearing native chicken. And there is a natural regeneration because this native chicken has a brooding and brooding capacities. And whatever the government does in the name of poultry and poultry program and poultry investment, it is all with the improved birds or with the broiler or the layer. And you know, the improved birds does not have the brooding capacity. So we came up with a model by which we tried to look at the problems also in the poultry systems, and then tried to look at how we can come up with a decentralized chick production systems in a cluster of villages. How this native chicken can actually bring in diversification into a 1 acre of land, including the fruits, vegetables, and the cereals as well within the 1 acre of land. Then bringing in the decentralized healthcare system, and also promotes the foraging system within the 1 acre of land. Then we also try to look at that how the community institution, the common interest group can actually work together to increase the income from the poultry. And then we tried it with 5 states initially, subnational level, and then with the government we have done this kind of a indigenous chick production breeding farm with at least 200 plus, and at the household level it is more than 20,000 plus tribal households were engaged in this program. And if you look at that the kind of an income that they got, as well as the nutrition benefits that it brought in, that 30% of the these enterprises has received 80,000 to 1,20,000 Indian rupees as an annual